In this video, we're going to look at how to handle random read and write of large datasets using HBase. Materials in this video are based in part on the book HBase: The Definitive Guide. HBase is part of the Hadoop ecosystem, typically run on top of HDFS. It supports random read and write and scale to very large datasets using many machines. HBase is not a relational database, and it does not support SQL as a query language. HBase is considered a so-called NoSQL database, meaning it does not use the conventional tabular storage model of relational databases. HBase gives up a number of features of relational database, such as data consistency, to provide massive scalability. HBase is designed to support billions of rows and millions of columns. For example, it is a database that powers Facebook's messaging platform. HBase is written in Java. Now it supports APIs in many languages. HBase is a column-oriented database, meaning data is stored by columns physically instead of by rows. A row conceptually consists of many columns and can be up to millions. Rows form a table, and you can look up a row by its unique row key. The row key is like an index. In HBase, you can only have one index per table. There's no built-in support for multiple indexes, but such support is possible via extensions. Rows are sorted by their row keys lexicographically or alphabetically. Here's an example of how rows may be stored in HBase. Here we have 7 rows. The first column contains the row keys, row 1, row 10, row 11, row 2, and so on. You will see that row 10 comes before row 2. This is due to the alphabetical sorting order. To bring row 2 to right after row 1, we need to pad row 2 with a 0, so that instead of row 2, we use row 02. We mentioned that HBase is a column-oriented database where data is sorted by column. Columns are further grouped into column families to help with data organization and storage optimization. In detail, columns in the same family are stored in the same file on disk called HFile. And we apply compression on all the columns in the same family. At a first glance, column families is a very nice way to group columns. However, unfortunately, HBase supports only a few families due to limitations in its implementation. Family names must be printable, and column family name should be defined when a table is created and should not be changed often. To locate a column, you need to include its family name. That means there are actually 2 parts in a column name. The first part is the family name, followed by a colon, then the column qualifier, which can be arbitrary bytes. The actual data is stored in cells, and these cell values are time-stamped. You can explicitly set the timestamps. If you don't, the system automatically sets it for you. This means you can store multiple versions of the data values over time. The values stored in decreasing order, so the most recent value can be retrieved first. Here's an example of how time-evolving data will be stored in a row in HBase as multiple versions. Here we have only one row, whose row's key is row 1, and we have 3 columns. The first column is in green, the data column. We're writing to its cell at 3 timestamps, 3, 6, and 9. While in the second column, we write a value only at timestamp 8. And in the third column, we only write at timestamp 3. At the bottom of this screen, we show a table view of the same example, where we can more clearly see which timestamp cell values are written. HBase allocates space only for values that are present. Empty cells do not take up space. This means that if a column is sparse, where only a few cells have values, the column will only take up little space. Now that you are more familiar with how HBase stores its data, let's do an exercise. How would you use HBase to store all web pages in the world? Meaning for each web page, you would want to store its contents, its web links, its images, and so on. Also, we want to store all this information over time so that you can keep a complete record. Now take a minute to think about this, and we'll discuss the answer together. Have you figured it out? The first thing to think about is what should the row key be. Remember, the row key must be unique. For web pages, the URLs are unique, so you can set it as a row key. So each row will represent one web page. The next question is, what should the columns and rows be? For each web page, there is quite a lot of information to store, such as its HTML content, JavaScript files, images, web links, and so on. So how do we store all of these? In HBase, we are allowed to have millions of columns, So we can actually have one column for each thing we want to store. For example, we can have one column for HTML, one for JavaScript, one for images, and so on. And whenever a web page is updated with new information, we just write to the same row with a new timestamp. So we get to keep all versions of the web page content. So there you have it. In this video, we saw an overview of HBase, looked at how it stores data, and also an example of how to use it to store billions of web pages over time.